Hello.
Hey, Nathan.
Hello.
Hi. Great, great. Yeah. Well, you know what? I figured that since both of you are working together, one of you could share information with the other, so you don't need to both be present at the same time. So do you have something to show me, or
Yeah, but I pulled from GitHub like what Yamm did, and then
Mhm.
I have no idea what he did.
No worries.
So
Yeah, I can also explain. I mean, when we look over his code, I can explain what's going on there. If uh, I
okay.
think it's pretty much it should be in line with what we discussed, unless it's completely different. So I won't be able to.
Okay.
So this is your C++ program.
Yeah, C++.
But where is your
Uh,
where's the scripts? Where are the scripts where's the data being? All right. Okay, there you go. All right. So what he's doing there is what is this? Oh, train.bash. Okay, so he's got a bash script that's gonna cat the training file, presumably saved, into cleanup scripts, all cleanups.bash. Okay, so one script that's going to do all the cleanups, and then finally train and author equals like Twain, Mark Twain or something like that.
yeah.
Okay, so, which means it'll also cat Mark Twain.text. So that because what is it called? It's called train.bash. Okay, train Mark. So I presume he'll call it like train. What is it? Yeah, train.bash space Mark Twain, and not even .text, Mark Twain. That's all.
Yeah.
And then it'll automatically cat the Twain.txt file, pipe it through the cleaners, and then the output of that goes into your C++ model trainer, and the author is that file Mark Twain .model or something that will be written. Okay, right. Let's take a look at all cleanups.bash, because the C++ part is pretty straightforward. It was really, in machine learning and data engineering, 99% of the work is before you get to the number crunching.
Yeah.
So we can take a look at that.
Okay. Is this a cleanup? No.
I think
Oh,
no,
right
I think
here.
it's
Right
called,
here.
what was it called? All all cleanup scripts, and then there. Oh, he's only got one thing there.
Yeah, we
New
only have
lines.
one here.
Oh, I see. Okay. All right. How about this? Okay. So why don't I give you guys a template of what this should be like? Yeah.
Yeah.
And then also it's going to be a bunch of different scripts that we'll write. Or you guys will write, but I'll write the first few with you. It'll only take about 10 minutes or so. And then you can just follow the model for the rest of it. How about that?
Okay. Okay.
Okay, all right, good. So let's take a look at his yeah, this is cleanup scripts.all. All
Yeah.
cleanups. Yeah, all right, let's go to all cleanups. All cleanups. Okay. All right. I see. I see. And it's gonna. Okay. All right. So now get rid of everything following the pipeline. The pipeline is that vertical bar.
So all of this.
Yeah, and then get rid of the pipeline also, and say backslash there. Just formatting it, formatting in a way that will lend itself for easy changes by you guys. Okay, all right. So tab in. Right, one tab is enough. Yeah, all right. Oh, 4 spaces actually. Yeah, don't do tabs. Yeah, right. Yeah, right. So now put the pipe symbol, vertical bar. Okay, I think the first thing we can do is turn all uppercase into lowercase. Yeah, how about
Okay.
that? All right, so the command to do that is very simple, and it's a stream. It's all O of 1, so it's just flowing through a pipe, and as it's flowing through the pipe, it's going to make changes. So it's like you can have any of these chained, any number of those chained one after another. It doesn't change the complexity of the overall cleanup because they're all O of 1. Yeah. Okay.
Yeah.
So all right. So you're going to say tr space, yeah, space uppercase A dash Z, uppercase A dash Z,
A-C.
yeah, space lowercase a dash Z. Okay, now save this file. Oh, hit enter, hit enter, hit enter, and then save this file. Right. You saved it. Okay.
Yeah,
All
I
right.
saved it.
Now Yeah, all right. So now type in your console, go to the console and type cat. I think what was it called? All authors, data/authors, is it? Data, type data and then hit tab.
Data
Tab.
tab. No,
Tab,
it
hit tab.
doesn't
It's
work.
not auto completing. Maybe so
No.
try dot/data. Or you can just do an ls. We can find out. Where we need to find out where that all authors thing is. Just give me a sec. I need to get my phone.
I think it's in cleanup scripts. So
Yeah, okay. Oh, you
yeah.
know, he's in cleanup scripts. He's got an authors. He's got the data directory in the cleanup scripts directory. Well,
Yeah.
we can organize these. Okay. Oh, you're in the cleanup scripts directory, but where is the data? Where is the data files? Where's the data
data
file?
is like out of the
One level up. One level
yeah,
up.
one
One level up.
Yeah.
Yeah. Yeah. I say that. Okay. All right. So now, so cat. So say type cat space dot/. I think it's authors. Yeah. Capital A authors.
authors.
Capital A and tab.
Okay.
No, what about you see? Oh, there's data/data/authors.
Data.
Sorry, data/.
Oh, right here. Yeah.
Yeah. Okay. Now hit tab one more time. Let's see what he's got in there. Now, I thought it was Mark Twain.
Oh.
Yeah. Okay. Well, let's try Shakespeare. Okay. Yeah. Type S, capital S tab. All right. Now pipe that through less just to make sure that less exists and all, so you can see the output.
Pipe it through what?
Less. LES.
Less.
LES. Yeah. Right. Yeah. Hit enter. Great, it's there. So Q out of this. Hit Q and it'll take you out of this. Okay. Now, can you increase the size of the console so that you're in the terminal? This is your is this your special Ubuntu terminal that you downloaded?
Yeah. That's the.
Yeah. All right. Pretty cool. Pretty cool. So because Yamm, when I did this with Yamm, he also had a Linuxy shell, but it was actually not Linux. It was something like, oh, you were there at that meeting.
I was there.
Yeah, it wasn't. Yeah. Right. Okay. So cat. All right. So now up arrow, get the previous command back. Now and then get rid of the less part. All right. Now pipe that to the script that we just wrote. What is it called? I think it was called train.bash. I think it was called train.bash.
So I would have to go in.
Actually, I don't think it was train up. I think it was cleanup scripts / all cleanup or something. Yeah, I think it was cleanup scripts.
All cleanups.bash.
Yeah. That's the one. Where is it?
It's in.
I think it's in cleanup scripts.
Cleanup scripts.
Yeah, clean and then tab. Clean tab. Tab. Hit tab.
Oh.
Yeah, clean. Oh no. Oh, you don't have cleanup scripts. You are /. Yeah. /all. /all clean. Oh wow.
Oh, like that.
All right. Now do a head of that. Head means it'll just give you the first 10 lines just to see if it's all working.
So pipe it into head.
No. Yeah. Pipe it into head and hit enter. Great. Okay. Now up arrow. Okay, and then backspace and just get rid of our cleanup scripts. Leave the head in place. No, you get rid of everything and just say head, right? So you can see what it is before. No, get rid of the cleanups, our cleanup scripts. Get rid of the /cleanup / all cleanups. Backspace. You can just backspace. Yeah, get rid of it. And the vertical bar and vertical bar. Okay, now if you hit head, you'll see the exact same thing before it was pre-processed. Oh, I can't tell the difference. You can't tell the difference.
No, there's no the capitalization. Yeah.
Okay. All right. Okay. So now let's go back to your script now. So we know that part works. So let's go back to your script. All right. Now, tab, space, and then vertical bar, backslash, hit enter. Right, vertical bar again. Now, after having done that, the next thing we want to do is get rid of. Well, let's say we want to turn all the periods into /new line. So meaning that we want to break lines at every period. Yeah.
Yeah.
Okay. All right. So what we can do here is how they've formatted it. Okay, so it's a period .2 spaces. That's good. Okay. All right. So we want to convert all the right. So type sed. Space dash. Keep forgetting this. Dash e. dash E, yeah, space. I think it's dash E. We'll find out, right? And then start a quote, a single quote, a single
Oh,
quote.
single quote.
Yeah, and then say substitute S for substitute,
S
and then and then forward slash,
/,
and then you want a dot, but the dot has to be within square brackets to escape it, because the dot is actually a special character in meta in regular expressions. A dot means any character for the right. So you want to say dot within square brackets.
dot within, so
Or you can also say backslash dot, but backslash dot doesn't look so nice. So I'm saying dot within square brackets. Yeah. Okay. Now dot and then 2 spaces after that. Isn't that what it is? Yeah. Every period is dot and 2 spaces. And we want to be sure that you only replace the dot and 2 spaces, because you also have things like www.gutenberg.org. You don't want that replaced by a new line. Yeah.
Yeah.
And then sometimes you may have Dr. Dr. Anderson, right? You don't want that, all right? So you want to catch that separately, right? Now, and then after, and then forward slash, and no space after that, just forward slash. Right? Now we want to replace that with a /n. Yeah, that's a new line character, /n, and then forward slash, and then say G, right? G.
Oh,
G is global, meaning G means if there's multiple spaces on a line, don't just replace the first one, just replace all of them.
Yeah.
Right. If you want to replace
said
one, you
E
can just say
stand for?
G stands for, I think, global. Yeah, you said global, right?
Yeah. What does said E stand for?
I think a sed stands for stream editor. It's one of the very first commands that Unix people wrote. Yeah, at AT&T Bell Labs. So what it said is exactly all of the Unix commands except join are O of 1. Most of them, right? Typically that data engineers use is there'll be tons and tons of these little scripts, even scripts they write themselves, but mostly Unix commands. But the beauty of them is all of them is O of 1. So you can put any number of them in a chain and it doesn't change anything, right?
That is so
because
cool, though.
Yeah. And
so
the actual job these guys do, they're also super duper fast. Like TR is basically scanning a string, and from CS2A, scanning a string and replacing a single character is like super duper fast, right?
Yeah.
That's all the TR does. And it's just one thing, and it does it really well. So it is essentially the same. What you've got there is essentially the same as writing a C++ program with that thing in there. Yeah, because it's all so fast. Now, sed is a stream editor. It does something more complex than TR, but again, at the end of the day, it's very simple. Sed is what it does. It has a stream flowing through it, and then a command. I think -E stands for execute this command on the stream.
Oh, okay.
I think that's what it does. You can look up the man page later. In fact, we don't know that's what it's going to do, right? And the command is given within single quotes because we don't want the shell to cache the space and and things like that and mess with it. So we put it in single quotes so that it's given entirely to sed. Yeah.
Yeah.
All
So
right.
wait, do I have to end it with a single quote like this?
Yes, because you open the single quote. And then you got to say everything between the 2 single quotes is my argument to sed. Otherwise, the shell will split it up as 2 arguments and say, hey, sed, you got 2 arguments. The first one here and the second one, the space is gone. Yeah. So we want to make sure that all of that is preserved. Now, the S is one of the commands you can give sed. Okay. And it's one of the simplest commands. And we'll just restrict our attention to sed operating on one line at a time. It is actually possible to have sed and awk and all these things operate on multiple lines at a time. But operating on multiple lines is not an O of 1 operation if you don't do it carefully. Yeah.
Okay. Yeah.
Because you have to buffer it and refer to the buffer and things like that. It's a pain. So 99% of the use cases I've seen for sed out there in the industry, right? So I've been in it to a lot of places. And it is all O of 1 use cases for sed, and it's very simple. And these cover like huge use cases for us. What we need to do. So S says for each line that's coming in, you got to do some substitutions, and the substitution is, so after S you say this is my delimiter character. So whatever follows S, there's going to be 3 of those, and 3 of those means you get 2 chunks. Yes.
Yes.
The first chunk is the pattern that you need to look for, which is a finite state machine, which is it's a regular expression. A regular expression is a finite state machine. Yeah. So and the beauty of using a regular expression is that processing a regular expression is also O of 1 time. So you can have a complicated automaton there, But string aside will process that in O of 1 time. It's really cool. If you do compiler theory and things like that, I can teach you at some point, because I'll be retiring. But if you guys are interested, I can just teach you these things because it's really cool the way the finite automata come out of regular expression, how you can convert from one to another. And it all leads into speech recognition, pattern recognition, data engineering, machine learning eventually, right? So, so it says, I want to replace that pattern. And the regular expression grammar is separate, and you can look it up. It is very simple. Dot slash stands for any character. So any character meaning any ASCII character is one character, right? And then a star says any number of repetitions, including 0 repetitions of just the previous character. So if the previous character is dot, it means it's any number of 0 or more repetitions of any character in the alphabet of the language.
Wait, sorry,
So
repeat that. I didn't
So
follow
a dot, yeah.
that.
Yeah, okay. So suppose I said, so this is a regular expression, it's a regular expressions 101, right? So it's really powerful, regular expressions, and it's good to know. And it's basically an extension of what people are used to with Windows, wildcards. But wildcards in Windows are actually a trimmed down form of regular expressions that already existed in Unix and AT&T Bell Labs. So a regular expression is basically a bunch of characters that you can expand out like a wildcard into a whole bunch of things. So a star essentially says any number of repetitions of the previous character. So if I said a star,
yeah,
okay, that will match nothing at all, because zero repetitions of a is nothing, an empty string. It'll also match a single character a because one count of a. It'll match AA because 2 of a's in a row. But it won't match BB or AB. It'll only match any number of repetitions of A.
Okay.
How about this? Okay. Hit Control Z for a sec. Control Z. Yeah. We can hit. Oh, you can go to the console. Can you go to the console? We'll just go to the console. Yeah. All right. So here. So type grep and hit enter. Oh no! Before you hit enter, GREP.
EP.
Right. Yeah. Space. A star. Within quotes, because the star will be picked up by shell, right? You want to make sure that shell is your regular expression is protected by a star. Yeah, right. Hit enter. So grep is another very popular common command in Linux. Hang on, I got to do a time check. Okay. Yeah. Okay. So it's a very popular common command in Linux, and all it does is that it does G. You remember you said global. Okay, for sed at the end, yeah. So that says global regular expression, replace and print. So that's all it does, right? GREP. I think that's what it means, stands for. I don't know, right? Maybe I'm just making up shit. Okay. So now grep is also just like cat. If you give it a file name, it's going to look for that pattern in that file. Right? If you don't give it a file name, it's going to look for the pattern in CIN. So now it's looking for the pattern in CIN as though it's a file. So if you type now, if you type A and hit enter, okay, it matches. The output is also A.
Yeah.
Right. It's A came out of grep. That's why it's red. Yeah. Now type double A. Type 2 A's. That also matches. Yeah. Now type a blank and enter. Just enter. Well, it matched, but it printed the line, but because you got 2 blank lines there, right? It matched, but there's nothing to show in color. That's all. Okay. Now type AB. Well, it matched the A in the string, but it didn't match the Z. Yeah, it doesn't match the A, right? So, and then again, all right. So hit Control C. Up arrow one more time. Up arrow, but before the A star, you can put an anchor saying don't match A anywhere, only match A at the beginning of the line. Okay, and the anchor for the beginning of the line is up arrow, the caret sign. So shift six. Not there. It has to be at the beginning of the line.
Not there. Oh, like before A.
Yeah. Now hit enter. Now it'll match. It'll match A, but it'll match AB, but it won't match BA. But the previous one would also have matched BA. The previous one would have matched BA because now A is not a standalone character. It also has a second character of an invisible character. That's the up arrow sign. That's the beginning of line. Yeah. Now, if once you've been playing around with Unix for a while, a lot of Unix commands use the same kind of regular expression terms, like, if you're in VI or Vim, yeah, the editor. That also uses, up arrow, that caret sign to get to the beginning of the line, dollar to get to the end of the line. Grep also uses dollar for the end of line marker. So there's a lot of cool things you can use. And the beauty is that the exact same regular expression grammar is used in a zillion commands in Unix. Once you master regular expressions, you automatically mastered lots and lots of Unix commands, right? So let's go back to our script. Yeah. It's really cool. It's really cool. So let's go back to your script.
Okay.
Right. Now close the quote. Close the quote. Oh no. Before you close the quote.
Slash
and then
G.
and G. Yeah. All right. Yeah. Close the quote. Hit enter. Hit enter. Right now, save this file. Save this file. And now, have you saved it?
Yeah, I
Yeah.
saved
Go
it.
to your console. Yeah. Go to your console. Up arrow many times until you get that Shakespeare thing.
Is it this one?
That one. That one. Yeah. No. Control L. Go to the top of the line screen. Control L.
Control L.
Yeah. Right. So hit enter. Oh, something's funny here. Why did it break up all the spaces? Wait a sec. I see. We want to. Oh, I'm so sorry. Okay, see here, this is a funny thing. There was a guy next to me in my office at SRI. He also used to be so crazy about regular expressions. So anytime, and both of us, even though we've been working on regular expressions, sometimes we get bugs in regular expressions, just like C++ bugs. Okay, so it doesn't match, or it matches the wrong thing, it doesn't match. It always happens. And so when that happens, I think we had a deal. So when I get that, I call him and they call me, because it actually is fun to solve regular expression bugs. Okay, so I know what the bug is, so I can tell you what it is, and you'll encounter lots of these things yourself, and you can debug them yourself. Go back to your script. Okay, the only thing we want to escape is the square, is a dot. Okay, so put the square bracket immediately after the dot, right? And after the square bracket, put two spaces.
After the bracket?
After the bracket, yeah, two spaces. So what happened before was that the square brackets are also an alias for regular expressions to say any of a group of characters in here. So if inside the square brackets you have A, B, C, D, E, then that A, B, C, D, E star, that means any of the 5 characters can occur any number of times. So AA will match, AB will match, AE will match. Yeah, but ABF will not match. No, because F is not in.
Like earlier. Oh, yeah. I understand.
Yeah, it is totally worth, Nathan, both you and Yamm, I don't know how familiar he is with it, but it is totally worth to spend a couple of days even to get to the bottom of just two or three commands in Unix, sed and grep. Yeah, especially with a view to mastering different forms of regular expressions. And you cannot master regular expressions just by looking at things online and saying, oh, this is what it matches and so on. What you have to do is basically set yourself little exercises. Like I got a lot of text and I just want to pipe it through sed, and I want to convert it. I want to convert all Nathans to uppercase Nathans. Or I want to convert, Yamm to Yamm/Nathan. Or, I want to convert all new lines to something else. So to give yourself lots and lots of these little challenges and see what the output is. I showed you how to get the output, right? So you can create a script like this, and is Control Z, or save the script and go back and up arrow and pipe it to head. Head will make sure that the pipeline does not execute the entire file. And because it's O of 1, the cost of running the pipeline is only the cost of typing out the first 10 lines of the file, even though your file might be gigabytes big. Yeah, so that's how you test it. And if the first 10 lines is not enough, you pipe it to less, and then you can see as many pages as you want. And still you hit Q. Less will make sure that the process on the left side of the pipeline will get the appropriate Unix signals to say, well, you know what, I've got my buffer full, so stop and go to sleep. Give your CPU cycle to someone else until I'm done processing my job. Then I'll give you another signal to continue. Then you can fill up the buffer again. So the operating system, not just Unix, okay, Mac, Windows, all of these things, which support the pipeline and things like that, they're designed very well with all these things in mind, so that it is designed for people, like you and me, who are going to do these data processing tasks and look in lots of data, to make sure that you're looking at data, you're piping a huge file. It shouldn't tax the CPU, right? Because you're only looking at one page at a time.
Yeah.
So the operating system has all that in control. And it'll say, well, you take your time, right? Because just because you're looking at a file, huge file, carrying a huge file, I'm not going to tax the CPU because it'll just keep everything asleep and so on. Okay. So and now if you hit enter, up arrow and do that. Yeah. Do that. There you go. Okay. Now all of the dots got converted. A dot followed by two lines into two spaces. They all got converted. Okay. Now let's do one more thing. Okay. So let's go back to dash. Yeah. Go to that thing. Yeah. Hit enter. Hit enter. Oh no, you want a backslash.
I need a backslash. Yeah.
Backslash. Hit enter. Now here's the cool thing. Okay. And this is a pattern that you can leverage with Yamm and other scripts you're going to write. Tab in past the -E under the first quote. Now, what we're doing is not continuing the pipeline, but we're actually continuing the sed command. Yeah. Now get under -E, get under -E, get under -E.
Under -E. I should do spaces.
-E. Yeah, spaces. Yeah. -E. Right?
Yeah.
Yeah. Oh, I see. Type -E, type -E.
Type -E.
Yeah. -E. No, not pipe, just -E. We're not piping.
Oh, I didn't type.
It is the sed command itself continues over multiple lines.
Yeah, this
We're
I didn't type
the
anything
command
here.
itself over multiple lines. Well, it'll become very clear very soon. Okay. Now -E, and then we want to do the same thing as before. Yeah, it's a regular expression. You can copy that regular expression. We can change it, right? You can put the whole thing there. Yeah, put the whole thing, including the backslash. Right now, here the thing that we want to do is replace all the beginning of line characters. Okay, beginning of line characters.
Beginning of
with,
line.
Yeah, and I told you what the anchor for the beginning of line is. Yes, it's the up arrow.
Yes.
So we want to, and you do this, okay? I won't tell you what the regular expression is. We want to replace all the beginning of line characters with a special sentinel you're going to use. And let's say that special sentinel you're going to use is square bracket, uppercase S, close square bracket. So it's going to start, and then a space that says this is the beginning of a line.
Wait, square uppercase S.
So you type that. What you want to do is right. So now get rid of the square brackets now, because we don't need the square brackets there. Okay. Now type up the anchor for a line beginning. The anchor for the beginning of the line is up. Yeah, there you go. Yeah. Okay. That's what we want to replace. Yes. In the stream, that's the second thing we want to replace. You can have any number of that's why we have the continuation of the set command. Yeah. So and then instead of /n, you're going to say square bracket. So anything in the second part, second chunk of the special, there's no special meaning for characters. So square bracket it doesn't have special meaning. Only in the first part it has special meaning, like it groups things together. Dot is any character, star. So in the second part,
it will just replace it with the brackets, like
with the bracket, exactly,
including the brackets. Yeah.
Uppercase S.
Sentinel.
And then a space after that. We want a space
after that.
In fact, you know what? Let's use the terminology that we used at SRI. So instead of square brackets, just use angle brackets.
Angle brackets, okay.
Angle brackets, yeah. Okay, so that means it's the beginning of line. Yeah.
Yeah.
Okay, so now save that, and then run it up arrow and run your command. Yeah. Great. Okay. So now you have line beginning, right? Line beginning, and then exactly the same thing as before. Now we want to do the same thing for the end of line, okay? Because we know that every new line character essentially was a, oh, gee, you know what we did? Well, we can fix that easily. Don't worry about it, okay? So, all right. So what we want to do is you do this, okay? We want to replace the end of lines in another, extension of the set command. Essentially, eventually, right? What happens is when in this pipeline, you have the set command, and the set command itself is multiple lines. Yes.
Yes.
So imagine easily at some point you're going to have like 50 replacements, right? Maybe you have a ST replaced by Saint or Street, DR replaced by Drive or something like, right? You may have many of these, like 50 of these S commands. So at that point, what most people will do is I'm going to take that entire set command and put it in a separate file. And then invoke that file from here, which is what Yamm was trying to do. So let's do that.
That's what we were trying to do earlier. Yeah.
But I'll show you a nicer way to do this. Okay. So now triple click on line 8, 6, and 7. And copy that into your clipboard and delete that. Copy that into your clipboard and delete.
Select all.
Yeah. Select all. Delete that. Okay. Copy that into your clipboard and delete that. Right now, but here you're going to say tab in, and vertical bar, and you're going to say, hang on, one sec. Okay, let me think about the best way to do this. Here, you're going to say, what are we doing in there? For now, we're just going to call it cleanup. Yeah, we'll call it pre-cleanup. Okay, we'll call it pre-cleanup. You can come up with a better name. Okay, pre-cleanup.sed. Okay, pre-cleanup.sed. Okay, sed. Okay, it's a sed. It's not a shed. It's not a shell script anymore. Right now, backslash there.
Backslash.
And now edit that file. Save this and edit pre-cleanup.sed.
Wait, what? Open
In
a new
directory, in the same directory, create a file called pre-cleanup.sed. Okay. Now, edit this file. Now here, instead of using the magic characters for shell, we're actually going to use the magic characters to say invoke sed itself. Okay. So right at the top, you say hash, vertical, exclamation mark.
Oh.
Yeah. Hash, exclamation mark. Slash USR. No, I think it's actually go to the console for a sec and type which said user bin. Okay, so say slash USR slash bin slash said space dash F space dash F. Yeah. What that means is that sed will now read this file, right? This script file, and I think you need dash F. I think it's dash. I think so, right? No, dash, not slash.
Oh, dash.
Yeah, dash F. No, one dash. No,
one dash.
I think this is it. We'll find out if this is not it. Okay. Now go inside the file. Yeah, first line. No, in the first line. Go to the first line. Yeah, first line. And actually get one more enter, right? We'll start in the second line. Okay. Now paste what you had. Now get rid of sed dash e and everything. All right. Dash e, that can also go. I think, right? I've probably forgotten the syntax for sed. Get rid of that. And then I don't think you need quotes anymore. You can get rid of the quotes because it's cleaner this way. If it's a shell script, you need to have escapes and all, right? So get rid of the quotes. Yeah, there you go. Excellent. Right. And in fact, you don't need to indent it either because, you can all start line 1 if you want. There you go. Right. And then you don't need backslashes to go to the next line. There you go. Okay. So now you can put all your replacements in here. One replacement after another.
Wait,
okay.
It's that simple?
Yeah, it's that simple. I think so. I don't know. The proof is in the pudding. After we run it, we'll find out. Okay. So hit enter. Now you can substitute the end of line character with this meta character, the tag for end of line, and you can use the same angle brackets, but instead of s, say /s. So that will be we have these 2 special tags. Yeah.
Okay. So the end of line character is the $sign.
Yes. That's right.
Okay, so it'd be like s.
No, the / goes before the s.
Okay.
Usually, conventionally, it doesn't really matter, but I think it's better. Now, here's the cool thing. Okay. Now, because you're using the / in your pattern itself, in your pattern or replacement, you don't want sed to be confused, saying, well, you know what? I'm giving you these things, and these are the chunks, the 3 chunks, right? Now, you don't have 3 chunks, really. If you look at it, you have 4 chunks, right?
Yeah.
Because the / that you have in the in your replacement string is also potentially be interpreted, right? So the way you do that is I'm going to keep that there. However, for the sed as the substitute command, I'm going to say my delimiter is not /, it is actually something else. So say at or something after the s. Say at or some other character, right? After the s. No, not there. After the first s, the command. After the command.
After here?
Yeah, after that, instead of the /, say @ sign. Yeah, and get rid of the /. You don't need the / anymore, right? Now replace all of the / with not the one in your pattern, or replacement, but you need to do.
So
yeah, there you go. You need one more at the very end. That's it. Okay. So sed means what sed doesn't say you always have to use /. It says, well, I'll use whatever character after the s as my delimiter.
Oh, that's cool. That's so cool.
Yeah, you'll find incredible, lots and lots of really nice features here. Okay, so hit enter, and save it. Now, go to your console. Do an ls-l. Let's see if this thing exists in the first place. Is it there? Where is the script that you created? Where is it? Oh, it is in src. It's in src, is it?
So I took go scripts.
You can move it. You can move it right there. I think.
Oh, I can move
Oh,
it?
you can move it here too. Yeah, you can. I think so. I don't know. It's VS Code, right? Okay, so yeah, we can just test it here. Okay. What were we trying to replace? Yeah. Now just type /pre-cleanup.set. It's gonna run because you got the magic characters at the top. Yeah. Pre and then tab. Yeah. Hit enter. Okay. All right. Oh, you got the exclamation mark hash opposite order. So go to the hit enter. Hey, all right, cool. Just type some junk, and hit enter. There you go. Oh, you know what? Yeah, put a space before the closing tag. Yeah.
So let's.
This is how you basically do your things and basically test them, right? Everyone you do and immediately test it. And so now what else do we need to do, right? So we have now you can save this and run your Shakespeare thing through it. Let's look at the output. And again, this is what you're going to do a lot, because you're going to be creating stuff, running your Shakespeare script or some script through it, looking at what you got and looking at the output and saying, is this good enough for my C++? Because C++ needs really good clean data,
Yeah.
okay? Because it's a sophisticated engine. You can task it with cleanup janitorial tasks. So you got to look at the final output in the stream and say, is this good enough for C++? So you got to pass it. Once you pass it, finally you can stick, Yamms or your train CPP, train model.twain. Okay, that's when it comes. But this is where you do it. So all right. So now let's go back to the script. So yeah, run it through. Run your Shakespeare thing through this up arrow or whatever it is that you had before. Oh, Control C out of this. So I think you have that Shakespeare. Yeah. Hit enter. It's not there. Oh, you are in the cleanup scripts directory,
Oh.
isn't it?
Is it like this to get out?
Yeah, you can do that. Because you have the buffer open, even when you save this file now, it'll save it in the other directory. So that's good. So yeah, hit enter.
Not found.
Oh, wait a sec. Where's your script?
It's all in cleanup scripts.
Oh, yeah. Oh, it's all in. Oh, so say dot slash, because dot is probably not in your path. That's why. Yeah. All right, save it. How come it says can just do pwd, right? Type pwd before the cat. Just in that script, just type pwd right at the top. Enter. Yeah, pwd says print the working directory or present working directory. Yeah, so we'll find out which directory the script is in. Just run the script. Okay. So this script lives in the src directory.
Yeah.
Is that where it is? So it's not in
Let's
cleanup
see.
scripts. That's okay. You can just invoke it. Yeah. All right. You can move it to the cleanup scripts directory. Yeah. Why don't you move it? You can just drag it in your nav. Drag it.
I thought it
from
was
there.
already in cleanup scripts. Yeah.
Can you drag it?
Where would I drag
Why
it?
don't we do everything in the same directory right now? Don't have multiple directories except the authors. The authors can be somewhere else. And later on, you'll have time to organize these things. Yeah.
Okay.
So you can have a scripts directory and so on. So get everything in the same directory. We'll just do everything in dot, right? So just create a working directory somewhere maybe and put everything there.
I'll just put it in source.
Yeah, put everything in source for now. Everything here?
Okay, that's the other script. No.
It's all here now?
Yeah, it's on source
Yeah,
now.
okay. All right, so run your command, run your command. Oh, I see. Because even all cleanups is here now. So you just need to get rid of the path. In your oh no, in the previous command. So in the previous command, up arrow, and then get rid of the / cleanup scripts. And say / yeah. Yeah, hit enter. Great, great, okay. Okay, okay, great, great. So that looks all right, right? Now go to your set thing one more time. Now let's do the easier. So we want to do one more substitution. What you want to do is you see that blank line there with open tag, space, and is it 2 spaces or one? Yeah, open tag, 2 spaces, close tag. Yes.
Yeah.
All right. So all you need to do is delete those lines. So what you want to do, I think, is say a D for delete. Right? It's all single commands, right? Single letter D, and then slash. And then you can say, oh, you say at because you're going to have a, this thing there. Yeah. So at, you can use any character, not just at. Okay. And then you say, put that tag there, copy that tag and put it there. The two of those.
Is it this time?
In the console? No, in the console. In the console, you have the open sentence tag, 2 spaces, close sentence tag. Further up, a little bit more, more. Third line.
Third line.
There you go.
Right here.
So you can put it there. And you want to delete those lines, yeah. And I think, and then put the @ sign again.
@ sign.
Yeah. Okay. I think this should work. Okay, save this and let's run it.
Do I have to
And now
put
we
G
should not see.
or-
No, because it's the
No.
entire line. It's the entire line, isn't it? Because your close tag will not be there until it hit the end of line. In the previous substitution, you only substituted the end of line with the close tag.
End of line.
Dollar. You type that. You type the dollar on the previous substitution. You substituted dollar with the end of line tag, that /s tag.
Yeah.
You did that, right? Now you're trying to replace that, which means that this thing contains the whole line. You don't need to do a G.
But won't this just do it once?
Yes.
Or is it?
And there's only one. You can't
There's
have
only
more than
one?
one on one line. Yeah, but you cannot have more than one of those patterns in a line.
Oh, D is for each line. Oh, yeah.
Yeah.
That makes sense.
And that is a pattern that has to match the whole line. You can't have anything else there. So now let's run this and make sure that that empty line is gone. Is it gone? Oh, line 6. Can you just Google set delete command format? I've forgotten, right? Just Google set delete command format or example. Okay. If you share the private, if you share the window, I can also tell you what to look at.
Sure.
There you go. Yes. That's one. Yeah, click that. So what is the format? Further down, they'll give you an example. We need an example. All right. Where is the example? Oh no, not delete on. We want to. Oh yeah. Okay. All right. Good. I think I know how. So we have the pattern, and the command is at the end. Yeah, these are things that you have to look up in man page, unfortunately, right? So let's go back to your script. So now get rid of the D from the beginning and put it at the end, after the last at, and then D. I think this should do it. Okay. I think this will delete anything that matches the pattern that you give.
Okay.
Yeah. No.
Unknown command at.
Oh, you don't have a D. Oh my gosh. Okay, let's go back to that browser. I thought I knew it, but I totally forgot then. Okay, let's further down. We want to delete a range, not a range, we want to delete a pattern. We want to delete a pattern, regular expression, further down maybe. Actually, delete empty
Oh,
lines.
right here, based on pattern.
Oh yeah. No, there you go. It has / and then the and then d. No, there you go. Right. It has the regular expression and d. That's what we typed. That's exactly what we typed. Right. So if you go back to our program, our script, let me take a look. So
Yeah.
that's what we typed, right?
Mm-hmm.
But it said it couldn't recognize the and it's just got exactly that.
Maybe in quotations.
Yeah, but I'll tell you an easier way to do this. You can figure this out later. If we had done that, it would only have been with a view to understanding the Z command more, like delete. But you can do that from Google. Yeah.
Yeah.
So what we'll do is, instead of waiting to delete the line until after we replace a tag and all, let's just delete it before. So go to line 3 and hit enter.
Enter.
No. We want an after. Yeah.
After.
Yeah, after.
So like right here.
Yeah, there you go. Right. Now substitute. What we want to do is beginning of line up caret. Yeah, caret for, and then any number of spaces. Yeah, 0 or more spaces.
0.
So how can I say 0 or more spaces? Yeah, it is. So
I do
it's
not
just
remember.
no, that's okay. It's the first time, right? So what you want to do is say space, and then any number, 0 or more, any number, which means it's a star. Star. Is dot star is what is called a cleany closure. Okay, if you do theoretical computer science, you'll understand. You'll come across this. It is actually a very nice concept. Okay, a cleany closure pretty much is a dot star. Okay, dot star is called a cleany closure because it actually represents anything in the language, because your language has alphabet. The alphabet has characters, right? Individual characters, but a dot can stand for any character, which means it's any character in the alphabet. And a star after that says any number of repetitions of this, including 0. So it stands for the empty set, but it stands for everything. So it's basically the power set. It's 2 to the n. Does it make sense?
Yeah.
So the cleany closure is essentially every string in the it's not 2 to the n. It's far more than that, because it's any number of repetitions too, right?
Yeah.
So it's the entire language in there. So put a / there. / But we want to delete that. We want to delete those lines, not yeah, you can put a D instead of the S. Put a D instead of the S. Oh, and then space. Oh, and then you want a $ at the end of after the star, meaning that you have the beginning of the line, any number of spaces, and then at the end of line. That's all. So everything, if you're saying just remove all of the lines that have only spaces in them, white space in them. In this case, only space. Yeah. Now, if you run this now, I think it should delete. It should delete.
So I should
and get rid of
this.
Yeah. Get rid of that. I don't know why that didn't work, because the man page, that Google page, the website. Extra characters after command. Where? Which line is
4.
It is that one.
It's the same line.
Okay, how about this? Okay, we'll leave the blank lines. We'll delete the blank lines. How do we delete the blank lines here?
Might be 2
right.
spaces.
No. It's just one space. Why is it not matching that? How about this? How about this? Okay, just substitute the 2 blank lines. Substitute that entire line with the word empty line. Empty line. Yeah, empty line. Right? And then make it all uppercase so that it'll stand out from the rest of the text, because everything else is lowercase, right? Yeah, and then slash. Now, if you run it, we should at least see empty line, right? We should at least see empty line in place of empty lines.
Oh, wait.
There, yeah. Okay, all right. So it is catching the pattern, but we haven't figured out how to delete that line, right? Delete lines that match that pattern. Why is it not deleting? You have to. I can look up my old set scripts and later on find out and let you know. But I'm pretty sure if you just Google a little bit, you'll find out how to delete empty lines inside. Okay, in a script.
Okay.
Delete. So what you want to look for is delete empty lines using sed in delete empty lines using delete lines matching regex, right? That's what you want to delete. You want to, in fact, Google it now. Delete lines matching a regex, right? Just Google it now because I'm very curious. Sed, yeah. And delete line matching regex. Delete line matching regex using sed, and put sed right at the beginning so that it'll know, regex, and put sed in the beginning of the line. Yeah, enter. All right, there you go. That's what we want. That's what we want. All right, so what does it do? I said, and so they have the pattern, and they have the pattern, and then D after that to delete.
Yeah.
Yes, that's what we had too. Oh no, he says it doesn't work. He does. Oh, great.
Oh,
Okay, let's
work.
take a look. All right, excellent. One or more of the special characters followed by blub. Okay, and then he's got a D. It's exactly the same. And what does -E do? What does? But why it didn't even recognize the pattern for us? It didn't even recognize the pattern. It says it was a syntax error there.
Yeah.
Just do a man sed on your machine, right? Just do a man sed on your machine. Yeah, just do man space sed. Yeah. Now, yeah. Further down, just hit pages. Yeah, page down, and dash. And do you have no regex? Or it's in here. For further down, let's make sure it doesn't have any. It doesn't have. Oh, it doesn't have any. Oh, it does have. All right, commands. Further down. We'll see. Where's the delete command? DDD for delete. All right, delete pattern space, start next cycle. That's exactly what we want. So delete pattern space and start next cycle. If no, we don't want the capital D. So that is the command we want. Let me take a look at that script again because it's so puzzling to me that why the hell does it not work? So why don't we do this on the command line? Just Q out of this. Yeah, Q out of this. Q, hit Q. Now just say sed space, and then within quotes, you say open. Oh yeah, that vertical. Yeah, slash / and then type ABC, and then D. So you want to delete lines that have ABC in them, right? And then close the quote and hit enter. Yeah, now type some junk. It should come out just like that. Yeah, great. Now type ABC junk. Gone, right? Now type some junk inside ABC inside of it. It'll still catch it, right? Yeah. Okay, that is also deleted. Great. Now go up to the Control C out of this, up arrow, get the sed command again. Now instead of ABC, use our pattern, which is up arrow, the caret sign, space star, and then $. Right? That is all empty lines. So you want to delete all empty lines. Now hit enter. Type some junk, you'll get it back. Anything you type, you should get back. Except if you hit an enter, you won't get another enter. So your blank lines are gone.
Yeah.
So why is it not working in a script? Now go kill this. Up arrow one more time. And then maybe the -E was a type of -E right in front. Oh, we did that -F. Oh, no, that was okay. Yes. Yeah. Let's check. Oh, I know what the problem is. Oh my gosh. Wow. No, actually, this is just a set script. I thought it was a shell script and we missed a backslash at the end. Where is, let's just, just copy that. Oh, you do have that. Dot. Empty line. Yeah, and it is replacing empty lines, right? It is replacing empty lines.
It is.
It's just not deleting them. And what is our command to delete? Right, now just get rid of the S and put the delete there. Get rid of the S on that line 4. Get rid of the S. And go to the end and put, get rid of that. Yeah, get rid of that and say delete and save it and run it. And let's see if.
Oh, it did delete it.
So what happened?
Why didn't it work the first time?
I don't know. Use different characters than / use upper the at sign. Maybe it's only S takes no, it can't, because if I'm matching a pattern. Oh wow. All right, so maybe it's just it doesn't arbitrarily take any commands. You have to say S. So you can just say / use /, right? So that's really that's really funny. Okay, so that will, if you run it now, we'll see the latest iteration of what we get. Yeah, hit enter. Okay, so is this clean enough, right? I see. Okay, so now we look at this and we see there's a problem. Yes, so we see there's a problem because the file itself had line breaks in there. Yes.
Yeah.
The file had line breaks, and that was a problem for us because now we have this. You look at the output now; it's all screwed up, isn't it? Because you have the partial lines with end of line character after it. So we can fix that. So let's go back to our script, and right at the top, what we'll do is, before we start replacing anything at all, what we'll do is replace all the existing new lines with spaces. How about that?
Okay.
Okay, now rather than do it here, we'll just do it in tr. So let's go to our tr command. So go to the other all cleanups.bash, or we can do it here. Replace all spaces. New lines with spaces. Yeah, we'll just do it in tr. Okay. One more tr right there. One more tr, and then what we want to do is open quote, and then I think you can do /n. Yeah. Now and then a single space, and then a backslash after that. So all that does is essentially replace new lines with a space character. Yeah. So now we can actually try this out. Go to the console. And just type that tr. Just type tr. And that's a really cool thing about Unix. Any operating system really is these things that we're typing in a script. You can always type them on a command and test out, and then go back and put it. So put /n within quotes. And it has to be within quotes, and space. Instead of space, put something else. Put a tilde character or something, so it's visible for us. Okay. Now, pipe Shakespeare. Pipe the head of Shakespeare through this, right? So type head of your. You can copy that thing. cat .. /data. You can copy that, but you don't want to do all cleanups, because that invokes your sed command. You can just get rid of all cleanups. Okay, and get rid of the. Okay, you can. By the way, you can also, instead of catting it into head, because it's all the Unix, the same kind of design philosophy. Instead of cat, you can just say head. That'll also work. So instead of cat, you just say head. Yeah, you can say head file, which means give me the head of this file, 10 lines of the file. That's also equally good. Yeah, right. So hit enter now. Great. Okay. So you see that all of the new line characters got replaced with tilde. Where is this? Are there any tildes?
Yeah.
There you go.
There's two right here. Then
okay,
one right
excellent.
here.
So now let's go back to our script. So we know that now all of these things will get replaced with a space. Yeah. Now let's go back to our script, our sed script. And then before we break up into multiple lines, let's also replace all multiple spaces with a single space. How about that? Yeah.
Okay.
So substitute S S
S.
/ and then here, space star. So that is two spaces.
Space.
The first space has to be there,
Star.
and the second space is optional. That means one or two or more spaces. No, actually, it's one or more space, right? So what we want to leave, anything with more than two spaces, we condense to one space. Is that how we can do it?
It would match with anything with one space, right?
It would match anything with that regular expression would match a single space and then zero or more occurrences, repetitions of that space, meaning that it will match one space, two spaces, 3, 4, and so on. But it won't match an empty. It won't match zero spaces because you got at least one space there. However, I'm thinking maybe this is not where we should do it. So hang on, new line. So we got the dot into new line is done, and then we collapsed all of those. We can replace the spaces later. So take that line 3 and put it after you delete the blank lines. After you delete the blank lines, hit enter. Now you can delete. Substitute multiple spaces with a single space, right? So with a single space and then G, and then let's do something cleverer than just a space. Let's replace all white space characters, not just a ASCII 32. So go to the first one where you have the first one on line. Line 4. Where you're going to delete. So change that space into a group of bracketed characters. Okay, square bracket instead of a space. Square bracket
right here.
Square bracket. And then space, and then you want a tab character in there. Can you get a tab inside of your VS Code? Can you hit tab? Oh, great. Okay, so you got a space and a tab in there. Okay, now you can close that, and then start. Okay, that means 0 or more occurrences of any combination of spaces or white space characters. Now you want the same regular expression in your substitute also. So you can copy that regular expression. All right, you can do that.
I would do this, right? Copy.
Exactly the same. I just want to make sure it's a tab because when you paste it, maybe it. See, turn the tabs into spaces now.
Maybe like a \T.
I don't know if it'll work. No, it won't work inside your square brackets. What we'll do is just hit the tab there. It'll do a tab. I think it's a tab character. Okay, I think it is a tab. Is it a tab character or not? Can you mouse in there? It is 4 spaces, is it? Is it converting all? It is converting all of your spaces into tab. All of your tabs into spaces. Is there any way you can configure VS Code to put your tabs back? I don't know if tab /t works inside of those special things. What you can do is you can Google for regular expression extensions for tab character. Okay, just Google for regex tab character regular expression. Read tab character. I think there's an extension somewhere. I think it's :tab : or something like that. Tab regular expression. /t. No. What is a tab character? No, not that's Adobe. Go look in Stack Overflow is better. Oh wow, it actually does. It does. The /t seems to work in there. All right. Okay. Let's do a /t. I didn't realize that the slash retains its meaning inside square brackets. /t, and the first one also. Space /t. Apparently, you can also do /s/t or /s for space. But run it now, and then we'll see if you're getting multiple spaces. All multiple spaces. Oh wow. Okay, so what did it put a single space inside of 0 spaces? Oh, you need 2 of those. So it match 0 or more. You want to match 1 or more. So you need 2 of those groups, one after another.
Oh, so it'd be like.
One more. Okay. Now it should leave. It shouldn't match the empty. It should match only 2 or more. So hit enter. There you go. Where are you getting these dashes from? Oh, maybe it was in the file. Dashes were in the file?
Yeah, maybe.
All right. Now, and you are breaking, and this is just a subscript, is it? Up arrow? Oh, all cleanup. It should. Oh, I did. And can you head -20, okay? And clean the screen and hit head -20. Let's see, 20 lines. This 10 lines is too short. Okay. Yeah, and hit Control L or something. Or you can just do less. Just get rid of head and do less. We'll just do less. Get rid of head, do less. Yeah, hit enter. Okay, all right. So it seems to be doing the right thing. And it's got a /s and why something is funky here. Okay. So this is what you're going to be doing most of the time. Okay, this will take up a lot of your time. What you're going to be doing is running it through, and you want to make sure and look at the output and look and see if it is, completely sanitized. And I'm looking at it here. I'm saying, okay, the S is in the right place, and all of them lowercase. That's good. But after www.gutenberg.org, why is it going to the next line? So let's look at the original source file to see what's in the, yeah, just do right here. You can do less. All right, there you go. No, right, right. No, oh, it went all the way there. Where's the www dot if you are not located? Where's the, yeah, if you're not located. Where is if you're not located? In the source file, where is if you're not located in the US?
Where are you looking? Wait.
Right at the end of
right here.
W, yeah, there after that, the next line is if you're not located in the US, right? So we want to know where that is.
Oh, right here, right here. Line 9.
Oh, there you go. Yeah, okay. So dot double slash, and after, okay, it broke there, which is correct. It broke there. But why did it replace the? Why did it replace the dot after the? Why did it replace the dot after the URL? You see that URL is www.gutenberg.org, and there's a dot after that. There's a period after that. Yes, in the source file. If you look in the source file, after on line 7,
line 7, right here.
Yeah, after it got you got a period after org.
Yeah.
But that period is gone here. Why did the period disappear? Yeah. So that we can debug.
It might be
so
because of the
no, we can look
alt
at the
cleanup scripts. I think it's because wait. Wouldn't it be because of this?
Yeah. So what we want to do is put that at the end after the three of those. Yeah, get. Oh, wait a sec. Oh, all right, okay. And you're turning everything into a single line. Where are you turning everything into a single? Where are you replacing the new line? Where are you replacing the new line? I thought you were replacing the new line somewhere. Where are you replacing the new line?
Right here.
Oh, you're replacing it there. Yeah, well, you can now replace it. You know that thing works, right? The escape character works. Let's just take that into the set script itself. So get rid of the TR, get rid of the TR, and go into your set script. Right now, yeah, and what were we trying to do? What did we get rid of there? It was replacing the new line, was it?
Yeah, replacing new line.
Yeah, so let's do that here. After right at the top, after the first one is dot followed by dot follow that dot followed, you're doing a new line. Yeah, right there. You can replace a new line, substitute /n with a space. With a space, and you don't need a G because there's only one new line in a line, right? So yeah. Now save that and run it through. Let's make sure that and then you replace the dot with this, and then dot with two spaces, dot with a new line, and you're breaking to the line. Oh, you delete the new lines, and then you replace a dot with a new line. So you go to the next line, and then you replace multiple white space, delete multiple white space, delete empty lines, and then you substitute multiple white spaces by a single white space. And then you, all right, then you tag the beginning and the end. Okay, all right, so that's how you basically read the steps in the cleanup process. All right, so let's run it and see what we get. And this time also you can pipe it through less, and let's see what the output is. You know, Q out of this, Q out of this, right? Up arrow and hit enter. So there's something funky here. Anyway, right, hang on. Oh, wow. Okay, I got to take off very soon. But I think, well, we'll do a little bit more, okay, for about 2 or 3 minutes more before I take off. But I think there's enough material here for you can just have your field day going into this and trying experiments and cleaning up everything. All we need to do is the next time we meet, you just need to do the pipeline, and in the output, we need to see clean text, okay? When you do the less at the end, we need to see clean. And the clean text, what I mean by clean text is everything lowercase, and do some sensible replacement like saint to st to say street, dr to drive, and things like that.
Yeah.
Doctor will get caught, who cares? All right, for now, we can leave these things alone for now. So do all the replacements you can. Out there, you should basically see all lowercase, clean, sanitized text, no unprintable characters. You need to have a beginning marker, space, and then space and marker on each line, right? So now the output of that is going to be hundreds of lines, some very long lines, some short lines, yeah, but no empty lines.
Okay.
Right?
Yeah.
Hundreds and hundreds of lines, which you can see through less, and all of them should be clean. And yeah, and then page through lots and lots of these, hit spacebar and less, and page through lots of them. Because when you page through, you can see all these funny characters. You see tilde marks, all these things, and you can go back to your tr or sad and delete them, right? In your pipeline. So that is how you clean up. And that's why it's called cleanup, because you're looking at the output and saying any speck of dust in there, you're going to go back and put an extra blockers, filters in there. That's why these are called filters. These scripts are all called filters, text filters. You're going to do these things. So now you know how to build up your sed command. And sed has a man page. You can Google. There's a lot of stuff you can do. And so essentially this output, final output, is going to be the input of what you're going to write as your, it's called an n-gram counter, okay? N-gram meaning you're going to count words, and you're also going to count words given a history of a particular word. Well, but that's the second step, right? The first step is just counting the, raw counts. So you get all the words, and then you count the words. That's it. Yeah. Now I'll show you what to cross-check your numbers. I'll show you what you can do, right? So before you go, right? And it'll be in the recording, so you can also look at it. So Q out of this, Q out of this, Q out of this, right? And so up arrow, and instead of less, you're going to type something. Okay. So here, the output is coming out, and what you want to know. Let's say, for example, you want to find the entire vocabulary of your text. Yeah, you want to find the entire vocabulary. So how do you find the entire vocabulary? To find the entire vocabulary, all you need to do is just replace all the spaces with new lines, and then each word will be on a line by itself. Yes.
Yes.
So just pipe this to tr space, and then space within quotes, and then /n within quotes. Yeah, and then pipe that to less, and make sure that all the lines are broken up into individual words. Okay, so hit enter. Okay, great. Everything broken up into individual words, right?
Yep.
So you can quit this now. Quit this now. Right? Up arrow. Get it back. Get it back. Now what you're going to do is you want to find the vocabulary, which means if words are repeated, you don't care. You just want to know all the unique words in there. Yeah.
Yeah.
So do a sort. Okay, sort. Instead of less, sort. Okay. So now sort. Now that makes it O of n log n at this point. Okay, number of lines. So it's not linear anymore, but that's okay. Even then, it'll be fine. Okay, so sort that, and then pipe that to less. We'll see if you get So now it's taking time because it's got n log n, isn't it? And it's got a lot of lines coming in. Why is it taking this much time though? It's taking this much time. Kill it. Let's go back to our script. Maybe it's just I think it's sort. Hit Control C. Hit Control C. Type SEQ and pipe it to sort. SEQ 10. SEQ 10. Right? 10, and then pipe it to sort. I think that is the right syntax for sort. Yeah, hit enter. Okay, this is 10 lines. All right, so 2 up arrows. Let's see how many lines you got altogether. All right. Get rid of sort and type WC-L. Right, that tells you how many lines there are. You don't need less anymore because it's just going to print one line, one number. WC dash L, let's just say WC, hit enter. So it tells you number of words, characters. Okay, so there's only 13,000 lines. Okay, there's 13,000 lines and 10,300 characters in the input in Shakespeare. It's only 13,000 lines and 10,000. How come this must be a very small file? Do an ls-l of that file, ls-l. It doesn't matter for testing purposes. You can have a simple small file, but I thought from Gutenberg it'll be many lines. Yeah, get rid of everything. No, get rid of everything and say cat the file to wc-l. Up arrow and get rid of everything except all cleanup can go. All cleanup can go and say wc-l there. So you're counting this file itself, wc-l. Right. Oh, there's only 1,500 lines in there. Okay, all right. So the file itself only had 1,500 lines. So what he downloaded was probably one small play from Shakespeare or something like that. Yeah, that's okay. I just wanted to do some sanity checks on the data. So up arrow, get the get our sort command back. Sort command back. One more. Get rid of the less. Get rid of the less and hit enter. Why is it not? No, it didn't sort. The last time it didn't sort. Yeah. Last time it didn't sort, right?
Yeah, it didn't
so
sort.
Now get the up arrow again and type less at the end. Maybe your machine was basically hung up on a heavy duty task. Oh, actually, you what? Oh, wow. Okay, I solved the bug. Yeah, it's not a bug. It actually did sort it. It sorted it, but your file had, after sorting, all of your empty lines in the file.
Oh, so like
right? So it's actually showing you all the empty lines.
all the empty lines. Oh.
Yeah, you hit space, you'll eventually get to the real content. Hit space, lots and lots of spaces. I'm pretty sure you'll run into the actual content. So all of the empty lines sorted to the top.
Oh, yes.
Yeah, all right. So now you can look at the vocabulary and already see that there's more things you need to do. Like you need to replace numbers, like numbers with 2 with TWO, 1 with ONA, and so on, right?
Yeah.
So you can put that all in the set script. But you got to be careful there that you got to replace 12 before you replace 2, right? And maybe you can just say you can have a separate set script for replace numbers with words. Yeah, and in there you can have elaborate set things there that replace phone numbers, that replace numbers in the right way so that it doesn't get messed up. Okay, so Q out of this. I want to show you one more thing. Okay, so up arrow, get after the sort. After the sort, vertical pipe. Now this command combination I'm giving you is the most commonly used among Unix people. Okay, do unique UNIQ, unique -C. Okay, sorted input, you pipe to a command called unique. Will in O of 1 time, it'll calculate how many times each line is repeated, and it'll print the repetition count at the top beginning. Now do a less of that. You'll actually see every line and the number of times that line is seen. Yeah, there you go. Right, each of those words, that's the number of times you've seen in the entire text.
Oh.
Yeah. So now, because it's -C means for unique, it says a -C means collapse all repetitions, but give me a count. -C is count. Now you got the count, but let's say you want to get the most frequently used words in here, right? So let's say the top 10% of your vocabulary, because there'll be outliers, right? Some people might say, instead of a heater, they might say hider or something like that, right? So it may occur exactly once in a corpus of 5,000 plays of Shakespeare, and those really are not going to affect your recognition accuracy or your machine learning model, because it's an outlier. It has very low probability in the end.
Yeah.
So what you want to do in most of these tasks is nobody can clean up data 100%. Okay, I think in my long year experience, I have found that you can never ever clean up data 100%. What you will do is keep on cleaning up and looking at the outliers and trying to minimize the number of outliers. So eventually you're still going to have funny characters. You're still going to have numbers that you can replace, right? And you're going to say, well, it's going to be dirt in the data, but it's going to be so small in quantity that I'm going to let it lie. Yeah.
Yeah.
So that in order to do that, you want to count these words by frequency and say, well, this is top, right? So go back to your right. Instead of less, replace less with sort space. No, sort space n-nr. Okay, -n says sort in numerical order. Okay, So it's not going to sort in alphabetical, it's lexical order, dictionary order. And R says numerical, but also non-ascending order, in descending order, right? So meaning it gives you reverse counts. Okay, now if you do less of that, you'll see the most frequent word at the top with the count of the word. No, dash NR. No, Q out of this.
Oh, I didn't put NR.
All right. There you go.
Also,
Right.
sorry,
So
yeah.
you had a blank line occur. There were 2897 blank lines in here in the input. That's not in the original file, right? Because you replace all the spaces with blank lines too.
Yeah.
New lines. So it says there are 29, that many, and then there's that many tag characters, and you see they match up too, right? 1579 lines, and they match up, beginning and end. Yeah, and then the most frequent word was "the," and it occurred 272 times. Now you hit space and keep going down. You'll see all of these words in the counts, and you can look at the vocabulary and say that gives you a very good idea of what you need to replace in your set scripts. Because you look at the vocabulary, all the repetitions are squeezed out, right?
Yeah.
And so if you look at the vocabulary, any dirt in there you can easily see, right? So apostrophes you need to handle, single double quote, all these things. Look at all these things, see how you can handle them, clean it up, and then the output should basically just be. And this, and you can also cross check. A C++ program, you're going to do a hash table with counts, and you're going to dump the hash table. Eventually, at the end, you're going to dump the hash table, right? You're going to say, "Here's my hash table." Output stream hash table. You're basically going to say word count, word count, word count, word count for all of the entries in the hash table. That's what your C++ do. And it's going to dump it in a file called twain.txt, right? But you can check those counts with this, with the thing you found, because this is just unigram counts are easy to produce even in Unix, right? So the unigram counts is where you're counting the words, but irrespective of their neighbor, of their predecessor, right? So instead of when I say cat, if I say the word "the," the probability that I say cat is higher than if I didn't say the word "the." Right? So that means that I can count words, not just raw counts by saying how many times the word occurs in the corpus, but I can also count words based on the context. I can say following the word "the," these are all the words these are all the words that follow with "the," and these are the counts. Following the word Nathan, right? These are the words that follow Nathan, and those are the counts. Now you can create second degree probabilities, right? Conditional probabilities. You can create the probability of seeing blue given the word color came before it. That is a second level modeling. We won't go there yet. So the first part is just getting unigram counts. So what you're going to do at the end is here, just generate unigram counts.
Okay.
Yeah. So is that enough? I actually got to go now. But is that enough material?
Yeah, that's
for,
enough. That's enough.
For you
Yeah.
and yes? All right, so get back to me, okay? Get back to me, because you really should take it to the next stage. You guys don't have enough, a lot of work to do on CS2C because you're done, right? So any time that you're supposed to allocate to CS2C, don't give it to the other subjects, because CS2C earned it. So you use that time for this, okay? So don't put it in the back burner. This is really useful skills. I can tell you, it is like super duper useful skills when you go out in the industry. Even when you're interviewing, right? So you can just do a pipeline when someone's expecting a command or a C++ program. So I can do this in a pipeline, all right? So I can handle the final output. I need a program. I can do that, right? Priority queues and all those things. But the pipeline is really important, and that takes up a lot of work, and a lot of interviews are also based on how people, pre-process the data into getting it to the final stage where you feed it to the deep net. Because you can't feed shit to the deep net, right? But then it'll also infer shit. So you got to clean up, lots and lots of other cleanups. But this is the most important part. So if you can get this done, let me know anytime. Even if it's after the final, I don't care. But I think it'll be better if you do it before the final. Yeah.
Okay.
So get it done and get Yamm together. Share this with Yamm and let me know. Or just send me email. Okay, just send me email.
Okay.
And outside of my lecture hours, I think I'm reasonably flexible. Yeah.
Thank
This
you
is
so
cool, this is
much.
cool.
Yeah, this is cool.
Yeah,
This is
no worries.
cool.
No, you guys have got a lot of stuff, and it's all going in the right direction too. So that is really cool. And it seems like it's positioned to basically just take a leap, right? Because I think, you know what to do. It's just that I think you just need to get familiar with the tools of Unix that
Yeah.
do things for you. So you just need to know, as the moment I told you about sed and sort and unique and things, you'll automatically go hunting for, other commands that do these things. In fact, Google for, not now, Google for the top 10 most frequent commands or something like that in Unix, and just get to know them. That's enough, because they'll do most of the stuff for you. Join is the one that needs a little bit more time to master, because it's a union of two sorted lists that takes O of n time. Yeah, because it has to zipper the two lists together. But you can figure out the syntax for join. And with join, you can do lots and lots of really sophisticated things, multiple files and these things. We won't get into that now, okay? But that is an entire thing in itself. I don't even know if they teach that in Linux courses. That's basically it. Thank you for your time, and I hope to see the output of this at some point. Okay.
Okay.
All right.
Thank you
Talk to you
for
guys later.
guiding
All right?
me.
No worries. I mean, I love to teach these things. Anything I know, anything I'm using for good in my life, I'm happy to share 100% free, because it doesn't cost me anything to share, and it's fun for me to share too. So I don't care. He's not, so anything you want, I'm happy to share. You can ask me anytime. Okay. I'm more than happy to answer any question you have. Thank you for your time. Right. Bye.
Bye.
Right. Bye.